Hello everyone. This video is a project walkthrough and demo of SquidShop Ecommerce. This is an ocean-themed e-commerce web app built with React and Typescript connected to a microservices architecture Node.js backend. All Dockerized and running with continuous integration using GitHub Actions. You can find all the source code on my repository here. Link is in the description. And without further ado, I'm just going to jump right into the demo. And if you're interested, I'll go into further detail about how I built this later on in the video. So here we have our front end deployed to Netlify. We can see the homepage has a catalog with all of our products. We have different styles for the on sale items, and we can see the review counts. We could select by department and search for products. We have our deals at the top. We can scroll through here, and we have our featured items all in this category. And there's a whole bunch of products here. And you notice this little alert down here. We have the demo data here. If the backend is not deployed at the moment, it won't be connected, and it will have an error status for us to understand that, but we can just use the demo data on the front end. We also have our banners here, and yeah, so that's the home page. And then if we want to search for items, we can search product catalog, and we can sort the items by price or name, popularity. We have all these filters here, and this can query the database or hit the backend. Let's say we found a product we like. We can visit the product page. We can see all the information here. We can go back to all departments or back to this department if we didn't mean to click this, and we can see related products. Scroll through here, and you'll notice it doesn't show the reviews yet. That's a feature that can be added, but for demo purposes, this is the product page so far. If we like this, we can add it to our cart. Back to the home page, we can navigate to our cart in the nav bar here, and this product name looks like it's too long for this box, but we have our cart total. Let me add another product here. We want to buy these two. We have our total. We remove an item, maybe buy another one, and say refreshing the page with the demo does not persist this data, but normally it would be, our cart would be persisted on the back end in production. So let's say we like these items, we can check out, and we're brought to the orders page. Now to get here, we can head to our account page. There's not a lot of settings so far. We just need to have an email to log in, and we can go back to our orders. We can see the order number, the address that we could put, and then the date we ordered, all the information we need. And this is just a sample order because we're not actually, this is just the demo data, and we're not persisting it in the back end since it's not up and running right now. Go back to my account. So if we're not in the demo, we can sign in. We have these nice pages here. This is built with MaterialUI, so we can log in or create an account, and then once we're logged in, we can view our settings. Yep, so that's all the features so far with SquidShop Ecommerce, and now I'm going to go into a more technical walkthrough of this project, how I built it, what are the features I added to this repository. All right, so before I go on any further, just to clarify, the goal of this project was building an e-commerce site and then also learning to build the back end, storing the product data, customer data. This gave me a lot of hands-on learning with Docker, test-driven development, CI/CD with the GitHub Actions, making multiple services, microservices, decoupling everything, and also was very security conscious, working with code scanning, and then automatically updating the dependencies if the tests were still passing. More on that later, but a whole bunch of features to make sure the project was maintainable. So again, you can visit the repository here on my GitHub, and let me just walk through this with you. There's a lot going on here. So we have our demo app hosted on Netlify. You can visit the link if it's still up. And let me scroll down here. So this is a mono repo. We have our GitHub folder. This stores the action workflows. We'll get more into that later. And then we have our different apps. So you'll see in a minute the architecture, but all these apps just in one repo to keep it organized for this sake of this project. And then these are all Dockerized, so we can spin them up easily with the Docker Compose file. So all you need to do is, let's see, to run this locally, you just need to clone it and then run Docker Compose up, and the front end is running on your local host. It's that easy. So that's the code. Here we have a bunch of badges. This is all the CI/CD. We have our continuous integration tests, our end-to-end tests running the Docker containers, and then making sure the Docker images are building, making sure it's deploying to Netlify. We also have CodeQL, more on that later. And then there's another Docker scan for vulnerabilities, but there's a lot of hard to debug weird errors with that, so I haven't dug through that. Not a high priority because it's not in production right now. So here's an overview of all the features we have. Basically, we're using TypeScript and React on the back end, NodeJS. We're connecting to MySQL and Cassandra databases also, and then automating a lot of stuff with GitHub Actions. So just a screenshot of our project, our video. So here's a project overview. I'm just going to skip to this page quickly. So if you want to pause, you can read through what I learned during this project, some of the takeaways. And then there's a lot of security features that I worked on. Following best practices and thinking more long-term so the project's maintainable, keeping things patched, all of that. Pretty cool stuff. So you can also see all the links. You can check my blog. And now we have the architecture here. So our end user web server goes to the web server. This is talking to the gateway API. This will route our traffic to the auth service, authenticating users, creating accounts. There's a MySQL database to handle all that. We also have our product service. We have our products database optimized for scaling with Cassandra for that use case. And then we have our order service. When users place orders, we can just store that in a MySQL database. And these are decoupled, so we can scale them independently. And then each database is for the specific use case, which is a good approach for the long run. Here's all the technologies we use again. And the README has some more features for the app to read through, which we've already gone through. Cool. So a note for this project, I enabled the security scanning. So we can scan our static code and get vulnerabilities here. Currently there's none, but we have all these. Can tell us some details how to fix the issues. And then we also have Dependabot scanning. So when there's some critical issues and we need to patch them, it will alert us. It can automatically create a pull request, and then since I ran unit tests and integration tests, it can automatically merge changes to packages because the core functionality is covered in these tests, and we're confident that our app still runs. So we can automatically update these packages, which saves a ton of time. So yeah, you already saw the website, talked about the technologies we used, CI/CD. So let me jump into that. If we head over to the Actions tab, we have a whole bunch of actions here. The main ones I'll show you. We have our Node CI, deploying to Netlify, continuous deployment, and then our end-to-end tests. So Node CI, mostly our unit tests here. Let me open up this action. We see the tests here. So since there's multiple services, there's tests for each of them. We need to run all of those jobs, and we install the dependencies, we lint the code, we test it, and then we upload the code coverage. Let me show you that quickly. So on a pull request, it should be I don't remember where I did that. Is it? Nope. One moment. No CI here. Okay, so on our job summary, we can scroll down here and get the test coverage output. Every time we have a pull request, we can see all of the changes. If our coverage is enough, we could set a threshold. I believe I set it to 80%, and then it shows all the percentage for each file. So every pull request, you can see all your changes. Super easy to look for areas of improvement. Oh, well, before I move on, one more thing, we have the end-to-end tests. So basically, let me show you the file for that. We're going to spin up all the Docker containers with Docker Compose, and then the tests, the Cypress tests, we're going to run on the local host. And this can take screenshots and everything and upload them, but I have that disabled. Pretty cool stuff. So I guess I could walk you through the end-to-end tests. We have basically opening the browser, acting like the user, and if we're clicking links, adding items to the cart, we want to make sure this logic is being handled properly. And then visiting different pages is loading without errors. All of that. Cool. I already showed you, mentioned the security features, walk through the workflow. So engineering decisions like why might we use a certain database? Overall, a monolithic architecture, we might have this API and one database. And all of our services or business logic in that API, all of our data in one database, right? So problems with this is that we can't easily scale. We have to scale the entire API, all of the business logic. This can be expensive, and it's not going to work in the long run. So one idea, we could make our server more powerful, more RAM, more CPU for this API, or the database, we could scale it vertically, beef it up. Maybe that's working for the number of users we have. Another idea is vertical scaling. This is even better. We could vertically scale, horizontal scaling, we could vertically scale each API individually, but the main idea here is that we're spinning up a bunch of instances of the API, routing the traffic from a load balancer, and this can handle way more requests. We can scale up and down as much as we need to. We could also horizontally scale a database or sharding. That's a whole different topic as well, though. So cons of this, or we might be reusing code. Managing this is more complex. Here I have a monorepo, which can get pretty messy at times, unless you understand what's going on. The pros, everything is decoupled. You can develop new features independently or run services. They can fail without affecting the others. We can also develop with multiple tech stacks. We're not confined to like one for each for the whole service where we have to follow that. So we have our gateway API. This is public facing, and then it basically acts as a proxy, or we can serialize metadata of requests coming in before we pass it on to the internal services. Again, we have our multiple tech stacks. Here I just use Node.js, but I could have used Python, Node.js, and Java for each of the services, if I wanted to. And then for this project, I worked with authentication. So we have our user service, basically the auth service. This is creating the JOT tokens, and it also needs to store the refresh tokens in a database, which connects to the user database. Email passwords, it will store that. This is in-house, but usually the best approach is to use a pre-built thing, not reinventing the wheel. Here, just for learning purposes, I wanted to get experience with JOTs. So again, here's everything coming together. We have our user MySQL database. Cassandra is a NoSQL database for the products. This is done because at a very large scale with millions of products, the way Cassandra can scale is way more optimized for this use case. And it's harder to, with sharding and everything, with MySQL, it doesn't work the same way. So it's way better to use Cassandra here. So with this microservices architecture, we can identify bottlenecks, maybe focus on each service independently and see what needs to be scaled. You can implement caching at different points and for each service or what endpoints you're working with. For this project, I had the monorepo, and then I was working on feature branches, writing tests for each feature I added, and then other continuous integration is linting the code, testing and building it, so I know when I push breaking changes and I can roll back. We also have code styling, enforcing with ESLint, so all my code is a bit cleaner or following the same conventions. And then for development, I have the test coverage that I showed earlier to make it really easy to see what I need to write more tests for. And then deployment. For this project, I was working with Kubernetes locally, kubectl. I didn't get very far with deploying it to production, and it was overly complex for the scope of this project. But locally and everything, I have Docker images, spin up these containers, but very user-friendly. Just run Docker compose up, and it will instantly be there. So I had a lot of blockers with environment variables and trying to pass these to the containers in production, and I needed to do more learning with this because I wanted to make sure I'm following best practices or securely passing it to the images, not building the Docker images with the variables set in there, in the source files, if that makes sense. So if you're interested in more projects that I've done, you could head over to my portfolio site. Link is in the description for that as well. But I have a lot more on there, and then obviously my GitHub, you can find some more projects. That's pretty much it for this project. I hope you enjoyed. Maybe you learned something. And if you want to connect with me, you can find me on my profiles here, shoot me an email, or learn more about me on my website. Thanks for watching and have a great day.